Okay, good morning students. My name is Suvas Vora, Assistant Professor of Electrical Department at SHREE, SWAMINARAYAN Institute of Technology. So start with the new topic. We can see the previous topic. In the last lectures we can see the SCHMITT triggering and the square wave generators. So SCHMITT triggering, in the basic comparator the feedback is not used and the op-amp is used in a open loop mode, यानी कि हमने जो कंपैरेटर देखा था उसमें फीडबैक लूप नहीं था, यानी कि अगर मुझे कहीं पे सेंस करके उसमें चेंजेस करना हो तो नहीं कर सकते, बिकॉज ऑफ दी op-amp में हम ओपन लूप मोड यूज़ करते थे. So the comparator circuit used to avoid such a unwanted triggering is called the regeneration comparator. So the SCHMITT triggering circuit is also called the regeneration comparator circuits. So this circuit is designed with the positive feedback and hence we have the regeneration actions which will make the output switch levels. So the SCHMITT triggering was invented by the Otto Schmidt early 1930. So SCHMITT triggering, inverting SCHMITT triggering. So the part of the output is feedback to the non-inverting input of the op-amp, hence is called the positive feedback comparator. So you can see the figures here. You can see the 5 main terminals. So we can give the input in the negative terminal and the positive terminal have the two parts or divided by the two resistance R1 and R2, and this point is called the V reference. So we get here two states. When the positive saturation is occurs, at that time the positive V reference, and if the negative saturation is occurs, at that time a negative get the V reference. So the R1 and R2 from the potential divider, and we can write this type of equation. So output is V0 divider, we can find the values of the R1, so R2 upon R1 into R1 plus R2. So basically the V0 output is the saturation conditions. So the positive saturation conditions is positive V state upon R1 plus R2 into R2. In similar way, the minus V reference will given the how to find. So the output voltage V0 upon R1 plus R2 into R2, but the V reference is negative, so our saturation is also negative. So the negative saturations minus V state upon R1 plus R2 into R2. Now the inverting SCHMITT triggering waveform, they have the two main concept, the upper limits or lower limits. So the positive V reference is for the positive saturation, so this one is called the positive V state is called the upper threshold voltage, it means the VUP, and the negative is the negative saturations when V0 is negative state, so is called the lower threshold voltage. So you can see here when to cut the sine wave of the upper limits, and at that time the state will be change of the square wave. In similar way, in the negative, when to cut the negative sine waves, at that time the state will be changed. So this is the inverting SCHMITT triggering. Now the hysteresis SCHMITT triggering. So the graph of the output voltage against the input voltage, this is called the transformer characteristic of the SCHMITT triggering. Here the positive to negative state will be changed when the upper threshold voltage will be triggering and negative threshold voltage will be triggering. At that time the state will be changed. So the hysteresis is also called the dead point or dead zone. Dead zone is here, these 2 points is this place, inner part of the hysteresis will be dead zone. So the hysteresis H is equal to the VUT minus VLT is equal to 2 times V state R2 upon R1 plus R2. But they have the conditions: if the input voltage is less than the lower threshold voltage, at that time we get the positive saturation voltage. If the greater than the upper threshold voltage, the value is minus V saturation. Here the V0 is not the output voltage, here the V0 is the previous state achieved. Now the non-inverting SCHMITT triggering, you can see here we can apply the input terminal in the positive parts. These are the circuit. Here again the upper and the lower threshold voltage will be set up, and we can find the equations of this. So this part is the V state, and here to here, when the state will be not changed, at that time the V in greater than VLT. Then after this part here, the again V in less than VAOT, and again change the state. So these are the non-inverting SCHMITT triggering. Then after we can see the difference between the comparisons of the comparator and the SCHMITT triggering. Then SCHMITT triggering is different of the UTP and the LTP levels. You can see the figures, and you can applying the KVL to the circuits. So the final equations is 2 times V state R1 upon R1 plus R2. So here you can see that the first stage is V0 is constant, positive V state. When the changing of this, at that time the change the values, so positive V state to negative V state. Again you can see find negative V state to positive V state. So the combine of these we can get the hysteresis circuits. Then after the square wave generators, the square wave generator is nothing but the multivibrators, and the multivibrators have the 3 different multivibrators. So bistable, monostable and astable. So bistable is nothing but we get the pure waves, they have no any pulse or no any triggerings. Monostables is we can get the pulse and like this, and at that the VD means the diode voltage, and these are the output. But the astable have the no any input signals, so this type of is called the multivibrator. So the monostables, you can see the monostable multivibrator is also called the monoshoots, and you can see the equations of these. So we can apply the voltage, at that time capacitor will be charged, and then after we get the output. So in the last lecture we can see that. Now the today's topic is the multivibrator using the op-amp, then triangular wave generators and the precision rectifiers. So stable multivibrators circuit, So the stable multivibrator is also called as a free running multivibrators. So stable multivibrators, it looks like the comparator with the hysteresis. It means the SCHMITT triggering, except that the input voltage is replaced by the capacitors. So you can see the figures. So the circuit has the time dependent element such as the resistor and the capacitor to set up the frequency of the oscillators. So this comparator has the positive feedback resistors R1 and R2 from the inverting SCHMITT triggering. So the stable multivibrator is also called the free running multivibrators. So it has the two quasi state and the no stable state, such as, so the no external signal is required to produce the change in the state. So the comparator values is to decide the time for which the circuit remain in each state. So usually the astable multivibrator oscillator between the two states is used to the square wave, and the circuit look like the SCHMITT triggering, except that the input voltage is replaced by the capacitors. So now they have the two conditions. The first, when V0 is the positive saturations and the feedback voltage is called the upper threshold voltage. So the equations is the VUT into is equal to R1 into V positive V saturations upon R1 plus R2, and the second one is the when the V0 is the negative saturations, at that time the lower threshold voltage is given. So the equations you can see that the VLT equal to R1 into minus V saturations upon R1 plus R2. So this part, the positive will be here because the inverting circuits, and this one. So when the power is turned on, at that time the output voltage automatically swing either to the positive to the negative saturation, since these are only the stable state allowed by the SCHMITT triggering. So now assume that so V0 equal to positive saturations, so the Vp is the upper threshold voltage and capacitor start charging to the positive state. So through the feedback path of the positive by the resistor Rf to the inverting input. So as long as the capacitor voltage V is less than the VUT, the output voltage remain at the saturation state. So in this part you can see that the switch triggers the output voltage from the positive to negative saturations part, and we have the get the Vp equal to VLT, which is the negative with the respect to the ground. So you, as a result, you can see that the conditions of the table expected that the capacitor in has the initial charge is to the VLT. So you can see that the capacitor will be charged, then again the negative V saturations, then again charge, then again the saturations. We have the upper threshold and the lower threshold voltage will be set, and at that time we can get the square wave. So upper part is the Vc equal to VUT, the output switch is positive to negative state. अब यहाँ पे output change होगा. In similar way, in the lower part, if the value is Vc, it means the capacitor voltage is less than the lower threshold voltage, the output switch is the negative to positive state. So they have the stable multivibrator. using the op-amp. Now the next topic is the trigger or the rectangular waves generators. So the output of the integrator is a triangular if its the input is square wave inputs, while the output of the SCHMITT triggering is the square wave for the any inputs. Now thus the output of the SCHMITT triggering is applied to the input of the integrator, and the output of the integrator as the input is SCHMITT triggering, then the circuit work as a triangular or rectangular waveform. So you can see the figures here. The two op-amp is used. The first one is called the SCHMITT triggering, which one is generate the square wave. This part is the SCHMITT triggering, and this part is called the integrator, which convert the triangular to the square wave. So the op-amp A circuit is a SCHMITT triggering comparator, while the op-amp B circuit is the integrator. So the output of the SCHMITT triggering is a rectangular waveform of the amplitude is positive, V state is applied. So it consists of the two comparators A, and first one is the comparator work and the second one is the integrator work. So the output of the comparator is the square wave and the amplitude is the V state and applied to the inverting input terminal of the integrator B. So the output of the integrator is a triangular wave and is feedback as input to the comparator. So the through the voltage divider is R2 R3. So let us the SCHMITT triggering is the positive V state, and this force current is V state by R1 through the C1 and charging the C1 with the polarities of the positive to the negative, and the produce the negative going ramp at is the output. So these are the मेन हमने यहाँ पे अपर ये हमारा पुल लेंथ है, जैसे हमने आगे में मल्टी वाइब्रेटर देखा, ठीक है. तो these are the upper values threshold voltage and the lower voltage, and we get the square wave. You can easily understand this type of, जिस तरह से हमको जिस टाइप का this one is the V state और नेगेटिव स्टेट, हमको जिस टाइप का स्क्वायर वेव होगा, जो जिस टाइप की एम्पलीट्यूड होगी, विड्थ होगी, जैसे कि यहाँ पे आप देख सकते हो कि 2.5 वोल्ट सेट किया हुआ है, तो आवर V state is the 2.5 state, then in this we can set the values is 3.75, here the 1 volt, here the 7.5 volts. So these are the get the triangular or rectangular waveform generators. Now the next topic is the smooth wave generator. This one is also get the triangular wave. So unlike the triangular wave, the smooth wave has the unequal rise the time and falls times, that it is main fall the negatively many times faster than its the rise positively, or the vice versa. So you can see the figures. The smooth wave generator can be implemented by the singly modify the triangular wave generators. Here the non-inverting terminal of the inverter is divided by the driven by the voltage set of the volt between the positive VCC to negative VCC by the potentials. So depending on the resistors R4, the R4 setting, the DC level is added in the output of the inverter B. So here we can change the cycles and we can see at the output of the inverting beam. हमको जिस टाइप की ड्यूटी साइकिल चाहिए वो. So as the output voltage of the inverter decide the effective voltage at the point P added the DC circuits DC level in the output of the inverter. So when the voltage at the non-inverting input of the integrator is negative, the duty cycle is less than the 50%. So the smooth triggering have the wide applications in the time-based generator and the pulse width modulation circuit. So the difference between the triangular wave and the smooth waveform is that the rise time of the triangular wave is always equal to the fall of the time, while in the smooth triggering the rise may be much higher than it falls of the time and vice versa. You can see here the triangular wave has the rise time is higher than less, lower time than higher less. So these are the difference from the smooth triggering smooth wave generators. So this circuit potentiometer is used. Now the output of the integrator is depends the waveform riding on the DC levels. So you can see the figures. So the duty cycles of the square wave will be determined by the polarity and the amplitude of the DC levels, and the duty cycle is less than the 50% is cause the output of the integrators be the smooth. तो हम यहाँ पे क्या करते हैं कि ड्यूटी साइकिल चेंज करके हम आउटपुट को ट्रायंगुलर वेव के लिए अप्लाई कर सकते हैं, यानी कि ट्राई कर सकते हैं. सो इट इज़ द इम्पोर्टेंस टू नोट दैट द फ्रीक्वेंसी ऑफ द स्मूथ waveform decrease when the voltage at the non-inverting input of the integrator is adjusted to positive to negative output or input. So these are the smooth wave generators. Now the last topic of the chapter is precision rectifiers. So recall from the basic circuit principles that the rectifier circuit can be implemented with the diode, and the diodes have the half wave rectifier or full wave rectifiers. So the major limitations of this circuit is that they cannot rectify the voltage below the diode voltage. डायोड वोल्टेज हम जानते हैं कि डायोड वोल्टेज 0.7 वोल्ट है. then these all the called the cut-in voltage of the diode. So the precision rectifier is a simple term, is a circuit that is carefully designed to act the exactly as the theoretical perform the rectifier would act. So the precision rectifier will make it possible to rectifying the input voltage of the very small magnitude, even less than the forward voltage drop of the diode. So due to this, output of the conventional rectifier is distorted, where the power is negligible and we want informations in the signal. So we get the type of the waveform or output, and this can be achieved by using the op-amp along with the diode, and this circuit are called the precision rectifier. So these are used to precisely rectified voltage having the amplitude less than the 0.7 volt. यानी कि हमको अगर एक्सेक्टली 0.7 वोल्ट का डिफरेंस चाहिए, उस टाइप के हमको वेवफॉर्म्स चाहिए, तो वी कैन यूज़ द प्रिसिशन रेक्टिफायर्स. सो प्रिसिशन हाफ वेव रेक्टिफायर्स. सो प्रिसिशन rectifiers, half wave rectifier is basically classified as the two main rectifiers. The first one is the positive half wave rectifiers and negative half wave rectifiers. Now start with the positive half wave rectifiers. So show the figures. The positive small signals precision half wave rectifier. Here the diode D1 is used in the feedback loop of the circuit. The analysis can be done by VI, यानी कि input voltage is greater than 0 and the input voltage is less than 0. So at that time the operating of the diode. So this one is the जब diode D1 is open होगा, at that time we get the output, then off हो जाएगा at that time the. So here there are the two type of case. The first one is Vi is greater than 0 volt. So consider the input voltage is positive going, and due to the high open loop gain of the op-amp is produced the high voltage here, the V0 dash. So the cutting voltage of the diode is 0.7 volt get the divided by the V0 dash, which is very high, and hence the device become on. अब इनिशियली में क्या होगा कि जब 0 से ज़्यादा वैल्यू होगी तो यहाँ तक हमको यहाँ तक फॉरवर्डिंग हो जाएगा, तो वी गेट द आउटपुट. So this circuit works as the voltage as followed. So the virtual ground is equal to the Vi. So we get the half of the positive cycles. Now the second condition is Vi is less than the 0. At that time the diode is of reverse bias. So the Vi goes the negative and the diode D1 reverse biasing, and due to the off of the D1 and the feedback path get the open, and the no current can flow through the resistance R. So we have the no get the negative half wave rectifiers. So see these type of the figures. Now the next one is the negative half wave rectifiers. In similar way the diode will be get the negative. नेगेटिव मीन्स के हमको डायोड की हम पोजीशन चेंज कर देंगे, तो जब यहाँ पे हमको पॉजिटिव में जब फॉरवर्डिंग में आउटपुट मिलता था, यहाँ पे हमको नेगेटिव में आउटपुट मिलेगा. सो यू कैन सी द फिगर्स कि यहाँ पे D1 ऑन ऑफ होगा क्योंकि यहाँ पे फॉरवर्डिंग बायस है, और जब रिवर्स बायस होगा तब हमको आउटपुट मिलेगा. So here again the two conditions. The first one is the Vi is greater than 0. The input voltage is positive going, the cutoff voltage is diode is 0.7. So we get the off conditions in, and this one is the on condition of the diode. So we get the negative half wave rectifiers. And the last one is the full wave rectifiers. So the full wave rectifier circuit accept the AC signals at the input and the invert either the negative or the positive half, and deliver both the inverted and the non-inverted half of the output. So you can see the figures. अगर हमको फॉरवर्डिंग चाहिए तो पॉजिटिव होगा और यहाँ पे नेगेटिव होगा, तो कब फॉरवर्डिंग होगा? सो व्हेन द ऑपरेशंस इज पॉजिटिव वेव, सो एक्सप्रेस इज आउटपुट V0 इज इक्वल टू मोड ऑफ द Vi, एंड द ऑपरेशंस ऑफ द नेगेटिव वेव सो एक्सप्रेस्ड एज V0 इज इक्वल टू माइनस Vi, यानी कि वी गेट द फुल वेव इन द नेगेटिव. सो दिस इज द सर्किट. सो these are the circuits for the, we can say that the precision full wave rectifiers circuit are precision absolute value circuits. Here again the two conditions, the Vi is greater than V0. अब यहाँ पे क्या होगा कि फर्स्ट द पॉजिटिव इनपुट वोल्टेज होगा, तब E1 में is force is the output of to the swing in the negative. Thus the D1 is forwarding but D2 is reverse biasing. So we get the positive waveform. So these are the circuits. And the second, Vi less than V0. Vi is less than the 0, so goes the negative. At that time E1 swings the positive, and the making the diode D1 is the reverse bias and D2 is the forward bias. तो सर्किट like this, सर्किट यहाँ से होके जाएगी. So that we get the final full wave output of the precisions rectifiers. So here today we can see that the stable multivibrators, then after the triangular wave generators, smooth wave generators, and the last topic is the precisions rectifiers. If any questions regarding this topic, you can mail me. If any query regarding this topic, you can contact me. My mail ID and the contact number is in your screen. Thank you.